Greetings, guys. This is Mr. Masango. I'm going to be tutoring you physical sciences. Thank you for subscribing, and don't forget to share to those who haven't subscribed. Please subscribe. Thank you. Good day, everyone. I hope you're well. This is Mr. Bongani Masango. I'm going to be tutoring you physical sciences. Thank you for subscribing and joining. If you haven't subscribed yet, please don't forget to do so. All right, welcome again. We're going to be doing the grade 10 physical sciences content for now, focusing on naming compounds. All right, let me start by saying we all know the periodic table. On the left-hand side of the periodic table, you have what we call metals, the exception being hydrogen there, the first element. And then on the right-hand side, we have what we call nonmetals. So we expect metals to lose electrons to nonmetals. For example, magnesium, which is in group 2, losing its electrons probably to sulfur, and then magnesium becoming positively charged, while sulfur becomes negatively charged. So they will form ions, okay? They will form ions. So for example, magnesium will become magnesium ion, and then sulfur will become sulfide ion. All right, so now let's start by just giving ions, ions in terms of really saying what ions are. We have the positive ions, which we called cations. All right, example can be that calcium ion. Then we have a negative ion, which we call anions or anions. Example being sulfide ion. All right, so now when we are talking about calcium, as you can all see that I've said 2+, calcium is in group 2, okay? And then this group is determined by its valency electrons, or the electrons on the outermost energy shell of calcium atom. It has 2 electrons, and then it will lose these 2 electrons, and the sulfur will be gaining it, or gaining those electrons to become sulfide ion. All right, so when we finalize the compound, is going to be CaS. All right, this is calcium sulfide. If you take a look, you will realize that the charges are balanced, +2, -2. So the net charge will be 0, as it is the case with all the compounds. All right, you will not see any charge, okay, attached to that compound. So this is calcium sulfide, because the charges are balanced, and they are going to give you a net charge of 0. +2 plus -2 equals to 0. So this is calcium sulfide. All right, let me give you other examples. If, for example, KPr, okay, MgO. All right, what do we call this? This is potassium bromide, okay? Potassium bromide, as you can see as well here, the charges are balanced, right? And then we write it as it is, but we'll talk about that. Magnesium, Mg2+, O2-. And then as you can see, the charges are balanced there. If you have, or when you have charges that are balanced, your net charge will be 0, which means that you will write the compound as it is. All right, you will not have any subscript that is added to it. For example, now, if you can see here, it's CaS. all right? And we wrote it as it is, CAS. KBr, and we wrote it as it is. MgO, we wrote it as it is. Okay, now I want you to focus. Here we have calcium sulfide, and here we have potassium bromide, and then we have magnesium oxide. Please note that when you have two, right, as you can see, 1 2 1 2 1 2, as when you have two atoms chemically bonded together, you are going to have the name ending with IDE. Okay, now let's look at magnesium oxide, IDE, potassium bromide, IDE. All right, so as long as you have two elements and that are chemically bonded together, you are going to have the name ending IDE. All right, obviously these are different. Remember, we are talking about compounds. These are different atoms chemically bonded together. All right, there's another thing I want to emphasize before moving on. That is the suffix, the prefix. I want you to focus on the prefixes. When we are talking about the prefixes, we are talking about the name, in this case the name that is written before the compound. Okay, what if you have, let me talk about this and this. This is what we call, okay, and this as well, this is what we call carbon monoxide. This is what we call carbon dioxide. This is what we call sulfur trioxide. Okay, I will show you how we got these compounds, and I will show you it's not something difficult. Let's look at the first one, carbon monoxide. Second, carbon dioxide. Lastly, sulfur trioxide. Now I want to focus on the prefixes. Okay, prefixes. When we have one atom, okay, let me use numbers. When we have one, we say mono. 2, di. 3, tri. 4, tetra. 5, penta. 6, hexa. 7, hepta. 8, octa. 9, nona. Then 10, deca. All right, so you need to familiarize yourself with that. For example, the first one, we said it's one oxide, so it's carbon and one oxide. Carbon mono, because there's one monoxide. All right, the second one, how many oxides are there? 2. Then it's carbon di, which represents 2, dioxide. The third one, how many oxides are there? 3. Then it's sulfur tri, for 3, oxide. All right, okay, I hope you got that. Now I want to continue. We don't only have mono atomic ions, right? We also have poly and polyatomic ions. Let me just show you now. Polyatomic ions, where you have a group of ions or compound ions that are mostly made up of non-metals. For example, let's take carbonate. All right, you need to know these polyatomic ions. They are not provided you need to memorize them. You need to practice naming. And then we also have nitrate ion. Okay, we have sulfate ion. We have, I'm going to just use these few. Dichromate ion. All right, and many more. Okay, the likes of permanganate ion, manganate ion, cyanide ion. All right, nitrite ion, phosphate ion, sulfite ion, and many more. But I want to focus here now. I'm going to use these polyatomic ions to show you how we get to a compound. Polyatomic. Okay, I'm going to use these polyatomic ions to show you. Now, I want to just start with this. Let me say number one, I'm going to say potassium. Okay, I wanted to use, let me use potassium is fine, but I wanted to use the transition metals as well. Okay, I'll just use this for now, and then I'm going to use sodium nitrate, and then I'm going to use, this is number 2, number 3, aluminium carbonate, all right. Okay, so I'm just going to use this few, and then I'm going to show you what is happening before we go to the last part, which are transition elements. Now here we have potassium. Remember we said this is a carbonate ion, so it's potassium carbonate. All right, here we have sodium nitrate. Here we have aluminium carbonate. Okay, so now remember I had said I'm going to show you how we get these compounds. Okay, let's start with the first one. Okay, potassium carbonate. All right, now I want you to notice this. I'm just going to remove this aluminium carbonate and put it here. Aluminium carbonate. There we go. So now I want to show you, this is potassium is in group 1, will lose its 1 electron, become positively charged. And then with carbonate ion, okay, as I have showed you here, okay, as I have shown you here, and then we are going to have these two coming this side. All right, you see, it was just K plus, now it's K2, and we have a 1 here coming this side. All right, a 1 coming this side, but we hardly write any 1 because you can see we don't write 1s since carbonate is only 1 carbonate there, so it simply tells you there's only 1 carbonate, and therefore that's why we ended up having K2CO3. Another way of doing this, you can balance charges. Okay, how do you balance charges? You want a number, when you multiply it by 1, then you are going to add it to this, and then you are going to get 0, or it will give you 2. What number is that? Okay, times 2 times 1, what are you going to have? We're going to have 2 here, positive 2, and I have positive 2 plus negative 2, and therefore your net charge will be 0, and that's what we are looking for. The net charge of compounds it's 0. All right. So on the K side, on what did we multiply? On the potassium side, we multiplied with 2. Therefore, we write it as a subscript there. What did we multiply with on the carbonate side? We multiplied with a 1. Hence, there's only one carbonate. We don't write 1, remember. Okay, because 1 times any number, it's that number. Okay, 1 times x is x. 1 times carbonate is carbonate. So we do not write any ones. Now let me show you this side. It's K, it's Na plus. Okay, just showing you the first part. And then and NO3 minus, and therefore you see the charges are balanced, guys. Whenever you see charges balanced, you write the compound as it is. Remember that. NaNO3, no net charge. Net charge is 0. Let's come to this one. Al 3 plus with carbonate ion 2 minus. Right, remember. And then what is going to happen? What is going to happen? Remember, if you choose this one of taking a number 2, putting it there, and a 3, putting it there, you'll need to protect that CO3. But anyway, you'll end up having Al2 CO3. Where is the 3 coming from? Outside bracket, from the aluminium. All right, lastly, I'm just going to use only this one as our example. Now let's look at aluminium carbonate. Another option is to say Al3 plus, CO3 2 minus, and then do what? Swap. Okay? Swap the charges and drop them. Okay? Sorry, swap the numbers next to charges. Swap them like this and drop them. Check. Initially we had aluminum 3, right? And carbonate 2. There we go. And then if I swap them, where is the 2 going? This side. Where is the 3 going? This side. Hence, bringing them down, you'll end up having the 3 this side and the 2 this side. That's one of those methods. Anyway, you choose the one that works better for you. Lastly, the transition metals. I'm just going to do a very few examples. Right, the very same way, transition metals have more than one oxidation state or oxidation number. All right, remember these are oxidation numbers here. Now, what is going to happen is, let's take nickel. Okay, what is the name of this compound? This is what we call nickel 2. Okay, for transition metals, we use Roman figures inside, if I should put it that way. We use to identify the correct transition metal with its correct oxidation number. Okay, if it's nickel 2 and so forth. All right, now this is nickel 2 sulfate. All right, okay, let me just use another one. What about this? FeO. This is iron 2 oxide. How did I know it's iron 2? Okay, we'll talk about that. And then the last one, maybe let me use aluminium dichromate. Okay, so now this is aluminium dichromate. Okay, so the first one is going to be Ni 2 plus and SO4 2 minus. And then what is going to happen is the charges are balanced. And what did I say? If the charges are balanced, the net charge is 0, so you write them as they are. It's NiSO4. Okay, that's how we got the NiSO4. The second one is going to be Fe 2 plus. All right, we said it's iron 2 plus, and then the O we know is 2 minus. Definitely, even if we didn't know this is iron 2, The only time you'll have a net charge of 0, it's when it adds to this -2, and we know that a +2 plus -2 gives us 0, so it must be ion 2. All right, if then charges are balanced, then you do what? You write it as it is, Fe and O. Okay, let's look at this one. It's Al3 plus and dichromate ion 2 minus. What happens is, okay, you have many options here, whether you swap them like this, there we go. You expect your 3 to be this side now. There we go. All right, here they are. 3 this side, 2 this side. I swap them, bring them down. There they are. So the 3 is this side and the 2 is this side. Okay, that's aluminum dichromate. Or alternatively, I said you do what? You multiply by 2 here, you multiply by 3 here, it will give you +6 and -6. You add the 2, you get a charge of 0. What did you multiply with here? A 2. Very good. Aluminum, you multiplied with a 2. What did you multiply the dichromate with? A 3. There we go. All right, guys, I hope you understood, and I wish you all the best. Thank you so much for spending time with me. I'm going to see you next time. Thank you.